Okay, I hope everybody is doing well. If you need some help on anything, come see me. I know this is a hard unit with all the momentum calculations. I'm going to try to do the last part of this unit, which is called impulse. If you have any questions, ask me. I would like you to pause your video. I want you to take notes in your binder or your notebook. Pause it, make sure you're understanding, write everything important down, and then show me so I can check off that you've done the practice notes. All right, so what you need to understand is impulse is force over time. So if you apply a force, the longer time, the less effect that force is going to have. Now, what we use to abbreviate the impulse, instead of using a certain letter, we use force time. So Ft is equal to force times time. Okay, so what it relates is like how much time is that force being applied. The units are, of course, force and time, so Newton's second, that is going to be most of the time. You could have Newton's minutes or something else, but Newton seconds is the most common. Okay, so let's take what some of the formulas are. So we have different formulas. So Ft is impulse equal to delta. This is a capital Greek letter delta. And what that means is change in. So change in the momentum, because mass times velocity is momentum. So impulse is a change in momentum, a change in mass or velocity. Okay, so for example, when a force is applied over a longer time, the effect is less. Let's take an example. So if I have a car and it hits a haystack, it would have less damage, but if it hits a brick wall, it's going to be applying the same force, but it would have much more damage. So I made my funny little drawings here. So the car hits the haystack, it's going with a mass and a high speed velocity. And after it hits the haystack, the pieces of hay go flying, but there's not a lot of damage to the car because the force was relative to time. Force was small compared to the time. So you have a lot of time, so it takes the time to go through that haystack. On this one, you have the same mass and velocity, same momentum. When it hits that brick wall, the force is greater, and because the time is so small, then the force has to be larger. So that car gets all crumpled up. So the impulse is the same, but we're having less force because the time is so big. Over here, you have less time, and so the force is bigger. Okay, let's take an example of a boxer. Now, boxers know this instinctively, or maybe they get trained, but they know that if someone's throwing a punch and they see that punch coming, they move their head back. So when that connects with their jaw, if they don't move their head back, the time that it hits their jaw is very little, and so you have a lot of force. But if you're moving your head back while the glove is in your face, then you extend the time, longer time, so it hits with less force. Okay, forces, another thing you need to know is that they have direction and a number, a measurement, so they are called vectors. We saw that in a previous unit. I just wanted to remind you, impulse is also a vector because it has a direction. Okay, so let's calculate impulse. Okay, some of the things that you need to know are these right here. Copy them down or know them. VF is final velocity, initial velocity, VI. F is for the force. Delta is a change. P is momentum. Little t is time. And F times time is the impulse. Okay, so let's take a look at some of the formulas. What I'd like you to do is take some time and write all of these formulas down in your notes. These formulas, I want you to understand them, when to use them, and they will be given to you. I'm not going to have you memorize all these. all of these equations will be on the test, and it will be on the final also. But you need to know how to apply them. If you're not sure what this means, well, delta means change, m means momentum, so change in momentum over change in time. Okay, again, force times time is impulse, and we can write it with words or here is with symbols. Okay, so let's take a question like you will have on the test. Okay, I want the impulse, the ball that has another ball with a force of this, so that's the force, over time. Now, I've given it to you in milliseconds. On the test, I won't ask you to do this, but I think this is a good skill to have. So if you are given that 1 second is equal to 1,000 milliseconds, can you convert that? Okay, so here is, let me cover this up. I don't want you to see this quite yet. Okay, so I'm going to convert 10 milliseconds into seconds. So I'm going to put this so that the milliseconds are canceling because they are dividing. These always go diagonal, and we'll take 10 times 1 divided by 1,000, which would give me this. Okay, so I'm going to take the impulse, force times time. I'm going to multiply those, and I'm going to get my answer. Okay, so on the test, you would have to do your data, which would be impulse equals 0. I'm sorry. Impulse is your question mark. Okay, it tells you the force is 20 newtons, and it tells you the time, which is milliseconds, but now we've converted it, 0.010 seconds. Okay, this is the second part, your formula. The third part, which is your numbers, and the fourth part, which is your answer. Okay. Another thing, just remember, impulse is momentum change, the change in that momentum. Airbags save your life because what it does is it keeps you in the seat, keeps you from moving forward, and so the force is applied over time. So you feel less force than if you were to hit the steering wheel. Crumple zones in the front and back of cars, they build in the front of a car and in the back, they build in an area which it will crumple up. It's made to crumple. So when it hits something else, front of your car dents in, and what that does is it extends the time, and so that there's less force that is hitting you inside. Okay, let's do another problem. Basketball player, it gives you the mass of the ball, comes to rest in her hand. Calculate the force applied. Okay, so we're going to do this 4 steps. This is how I want you to do it on the test. Oh, and by the way, remember, we saw this in another unit. Newton equal kilogram meters per second. I will give you this, but you need to apply it so you can get the correct units. Okay, so step 1, velocity. The first velocity, it says it's traveling at this, so that's what it starts out at. Okay, it comes to rest, so that means that the final velocity is 0. It has none. It says the mass. It asks me what the force is, and it gives me the time. Second, I want to choose my formulas. So remember up here are all your formulas. You're going to choose one that has all of these things. One that has force and time and mass and velocity. That is the one you choose. You wouldn't choose this one because we don't know the momentum. Okay, I'm going to put in my numbers. I'm going to do the math. 8.8 times 20 gives me 16. I'm going to put 16 over 0.2, which is my time. I get 80. Okay, and then I have kilograms, meters per second, divided by seconds, which gives me, which is this right here, kilograms, meters, and then this is seconds squared, because you've got seconds dividing twice. So that would be your final answer. If you put 80 kilograms, meters, seconds squared, that would be okay also. Okay, let's try the last problem on these notes. Here, I want you to pause it I want you to work it out the way up here, 4 steps, and then check your answer. So please pause, work it out before you just copy it down. Okay, hopefully that you've gotten the problem already worked out, and let's check answers. Okay, so I'm writing out my data. I'm choosing which formula has all of these in it. I'm going to multiply, and I'm going to get an answer. I can have 3 or 4 numbers. If you put 20.2, that is fine. And your units are newtons per second. Okay. I've got some tutorials also on my Taco page, so if you're not understanding, please try to watch those or come and ask me. I will be more than glad to help you. All right. See you next time.